afternoon, learners. That's Tshaka. This is just a continuation of electric circuit, so please make sure that you get the first part where we are talking about the Ohm's law. So for today I want us to differentiate between series circuit and parallel circuit. In grade 10 you learned about resistors and were introduced to circuits where resistors were connected in series and in parallel. In a series circuit there is only one path. There is only one path along which current flow. And then in parallel circuit there are multiple paths along which current flow. Remember, this is in parallel, this is in what? In series. So meaning in series circuit there is only one path along which current flow, but in parallel circuit there are multiple paths along which current flow. Now let's check. Remember that here we have been given the conducting wire, we are having a cell, and then here we are having two resistors that are connected in series. Remember that we have two lines that are drawn that are representing a cell. The longest part of the cell we are saying that is positive, and then the shortest one is negative. Remember that when we are talking about the conventional current it always flows from the positive terminal of the battery to the negative terminal of what? Of the battery. As we can see here, we are having the arrows. This arrow, it indicates that the current flow from this side, and then it passes through this resistor, and then here it passes through this resistor, here it is. Meaning this is the direction of the current that is flowing throughout our circuit. And then as you can see, the current that is flowing through this resistor is the same as the current that passes through this resistor. So that shows that the current flowing in our series circuit is the same throughout. The current that is flowing throughout our circuit is what? Is the same throughout. But now let's check the parallel circuit. As you can see, these two resistors, they are now connected in what? In parallel. Why am I saying that? It's because of when our current gets to this point, let us say that this is a positive terminal of a battery, this one is a negative terminal of a battery, meaning our current is going to flow from positive terminal of a battery, and then but immediately when it reaches this point here, certain amount of current will be flowing in this direction, and then another amount of current will be flowing in this direction. So it shows that when our current reaches this point here, it splits. So certain amount of current goes to this direction and then another goes to this direction. But immediately when they reach this point, the current that is flowing in this direction and the current that was flowing in this direction, they will have to combine, and then they flow as what? As total. But when they get here, it will split again, the other one in this direction and then the other one in this direction. So meaning these two resistors, they are now connected in what? In parallel. But for this one, they are connected in what? In series. Why? Because here we are only having one way of what? Of current. But here we have how many ways? Two ways. So it shows that these two resistors, they are now connected in what? In parallel. So that is why here we are having series circuit, one current path. Parallel circuit, multiple current what? Path. When there is more than one resistor in a circuit, we usually able to calculate the total combined resistance of all the resistors. This is known as what? As the equivalent what? Resistance. Meaning sometimes you will be getting the formula or the question that says determine the equivalent resistance. When they say equivalent resistance, they are saying that determine the total resistance of what? Of the circuit. Okay, let us assume, let me just say the resistance of this resistor here is 2 ohms, and then for this one is 4 ohms. For this one, let me just use 3 ohms, and then this one is 6 ohms. Now the question says that determine the equivalent resistance. Let us start first by A. This is circuit A, and then this is circuit B. When we determine the total resistance of the circuit, number one, we need to identify if whether the circuit is in series or in what? In parallel. So our circuit A obviously is connected in what? In series. So the formula that we use to determine the total resistance of the series circuit is RT is equals to R1 plus R2, because we are only having 2 resistors. And then what is the value for R1? R1 is 2 plus, what is the value for R2? Our R2 is 4. Therefore, the total resistance of this circuit, it has to be 6 ohms. Remember that resistor is measured in what? In ohms. But now when we check B, when we determine the total resistance of the circuit, I cannot use this equation, because this equation is for series circuit. But for parallel circuit, 1 over RT is equals to 1 over R1 plus 1 over R2. Remember, some other books, they refer to this one as RP. That shows that the total resistance for parallel connection. Okay, so 1 over RT is equals to, how many resistors are here? I have 1. 1 over how much? 1 over 3 plus 1 over 6, and then obviously 1 over RT is equals to 1 over 3 plus 1 over 6. You can put it in your calculator. We will get something like let me just determine the LCM. What is the LCM of 6 and 3? Is 6. 3 goes how many times into 6? 2 times. 2 multiplied by 1, here is 2, plus 6 goes how many times into 6? Once. 1 multiplied by 1 is 1. Therefore 1 over RT is equals to 2 plus 1 is 3 over 6. And then obviously we are looking for RT. I'm going to say RT over 1 is the same as 6 over 3. So RT is equals to 6 divided by 3 is 2 what? Ohms. Therefore the total resistance of this circuit is what? Is 2. And then remember this, this is just an advice. When you are given 2 resistors and then you are asked to determine the RP or RT for this, just know that the RT, it must be smaller than the value that is smaller in our parallel connection. Like for instance, between 6 and 3, which value is small? Is 3. Meaning when you determine the RT for parallel connection, the value that you must get here, it must be less than what? Less than 3. That is why here we got what? 2. I hope it makes sense. Equivalent resistance is the same as total resistance. Equivalent series resistance. In a circuit where the resistors are connected in series, the equivalent resistance is just the sum of the resistance of all the resistance. In a circuit where the resistors are connected in what? Connected in series, the equivalent resistance is just the sum of the resistance of all the resistors. So that is why here the definitions, they are saying that equivalent resistance in a circuit for n resistors in series, the equivalent resistance is R total for series is equals to R1 plus R2 plus R3. It will depend on how many resistors are given. So in a situation whereby you are given 3 resistors, obviously you'll make use of this equation, but you will have to say R1, R2 and R3. Let us apply this to the following circuit. How many resistors are given here? We have about 3 resistors. It's resistor number 1, which is 3 ohms. We have resistor number 2, which is equivalent to 10 ohms. We are also having resistor number 3, which is equivalent to 5 ohms. Let us remember that we are also provided with a cell. Our cell here, the longest part of the cell is positive, and then the shortest one is what? Is negative. Remember that the current is flowing throughout our what? Our circuit. Remember what I said earlier. The cell or our battery is producing the what? The charges that will be flowing throughout our what? Our circuit. And then when we divide the flow of charge with time, that's where we get what we call a what? A current. So remember that that is why sometimes we'll be connecting the ammeter throughout our circuit, the ammeter with the intention of measuring the current flowing throughout our what? Our circuit. So now let's check. How many resistors are here? We have 3 resistors. Let's check how they did it. The resistors are all in series. Are we together? Yes, because check, the current that is flowing throughout the circuit is the same. The current flowing throughout our circuit is what? Is the same. The current that passes R1 is the same as the current passes R2, is the same as the current that passes R what? R3. So meaning the current flowing throughout our what? Our circuit is what? Is the same. So meaning when we want to determine the total resistance, I can say that RT is equals to R1 plus R2 plus R3. And then now let's check. And then what is the value for R1? Our R1 is 3. Plus what is the value for R2? Our R2 is 10. Plus what is the value for R3? Our R3 is 5. So 3 plus 10 plus 5, it gives us 18 what? 18 ohms. Meaning 18 ohms is our total what? Resistance for this circuit. I'm now having this. This is my R1. It's equivalent to 5 ohms. This one is my R2. It's equivalent to 1,5 ohms. And then this one is my R3. Is equivalent to 2,5. And then lastly I have R4, which is equivalent to, let me just say 3. And then here I have my battery is 24. Let me show you something. Let me just connect an ammeter. Remember that the function of an ammeter is to measure the rate flow of what? Of charge. Is to measure the rate of flow of what? Of charge. Which is current. How many resistors are here? We have 1, 2, 3 and 4. All the resistors are connected in what? In series. Why am I saying this? Remember, we are having a positive terminal of a battery. We are also having a negative terminal of a battery. When we are talking about the conventional current is the current that always flows from positive terminal of the battery to negative terminal of what? Of the battery. So meaning here it is. Our current is the same throughout. Our current is what? Is the same throughout. So meaning, the first question that I want us to do is to determine the total what? The total total resistance? What is the total resistance of the circuit? How many resistors are here? Learners, how many resistors are here? Yes, we have 4. So RT is equals to R1 plus R2 plus R3 plus R4. What is the value for R1? Is 5 plus R2, 1,5 plus R3, 2,5, yes, plus R4, 3. So when you press your calculator, 5 plus 5,5, 6,5. 6,5 plus 2,5, 9. 9 plus 3 is 12 ohms. This is our total what? Resistance. This is our total what? Resistance. Sometimes you may be asked to determine the what? The current that is flowing throughout our what? Our circuit. When you check this current here, or this ammeter, it reads the total current flowing throughout our what? Our circuit. Meaning, if you want to determine the current flowing throughout our circuit, you must be having the total voltage, which is the voltage of a battery. And number 2, you must be having the total resistance of what? Of the circuit. So meaning, if I want current that is flowing throughout our circuit, I can say IT is equal to VT all over RT. Is correct. And then now let's check what is our V total. Our V total is what? Is 24 all over. What is our R total? Our R total is what? Is 12. Therefore, the current that is flowing throughout our circuit, 24 divided by 12, it must give us how much? 2 what? Amperes. This 2 amperes is what? Is the current that is flowing throughout our what? Throughout our circuit. Now let me show you something. There will be a time whereby I will be connecting the V across each resistor. I will be having V across what? Each resistor. Let me just say this one is V1, this one is V2, and then we have V3, and then this one is what? Is V4. Remember when we talked about the properties or the equations that we use for series circuit, there was a time whereby we said the V total, which is the V of the battery, is still the same as V1 plus V2 plus V3 plus V4. It will depend on how many resistors are there. So in this situation, remember that at this point we do have the resistor, and then we are also having the current that is flowing through it. So meaning, if we are asked to determine the V, we won't be having a problem, because V here, V is multiplication of current and resistance. Okay, let me just write it here. I'm sorry for this. V1 is equals to I R1. What is my I? My I is 2. Am I correct? Yes, it's 2 multiplied by, what is my R? My R is 5. Therefore, 2 multiplied by 5 is 10 what? V. This is the reading on what? On V1. V1 is equals to 10. Let us check V2. V2 is equals to I what? R2. What is my I? My I is 2 multiplied by 1,5, which is equals to 3 what? V. Are we together? Yes. What is V3? V3 is equals to I R3. What is my I? My I is 2 multiplied by what? 2,5, and then which is equals to 5V. And then now let us determine V4. V4, what is my I? My I R4. What is my I? My I is 2 multiplied by 3. And then 2 multiplied by 3, it gives us 6V. I want to show you something. For V1, what is our current? Is 2. For V2, what is our current? Is 2. For V3, what is our current? Is 2. For V4, what is our current? 2. What does this tells you? It tells us that the current throughout the circuit is what? Is the same. Therefore, I total is equals to I1 is equals to I2 is equals to I3 is equals to I4. Are we together? Yes. Now let's check. Let's check. V total is equals to V1 plus V2 plus V3 plus V4. And then what is our V1? Our V1 is 10 plus what is our V2? Our V2 is 3 plus what is our V3? Our V3 is 5 plus what is our V4? Our V4 is 6. So when you combine these things, you will get your VT as what? As 24 watt V. So this simply tells us that the V here plus V here plus V here plus V here, it must give us the V of what? The V of the battery. Because as you can see, this V here is still the same as what? As that V there. So please, my beautiful learners, be careful that the current throughout our circuit is the same if the resistors are connected in what? In series. But when we are talking about the potential difference is divided. You must check how many resistors are there. If we have 5 resistors, the V across each resistor, when you combine them all together, you must get the V of what? Of the battery.